Okay, the story of quantum physics starts from the talk from Kevin. We call it Kevin. Kevin said in physics world we have two cloud, black cloud like mendong. Okay, that is one. That is what is the medium that help to transfer, or what is the medium that fill the outer space? There is something that needed to carry light. Another one is black body. Okay, so what is black body? If in exam, right, question asks what is black body, you have to say it is idealized body that it can absorb all electromagnetic wave, or it can emit electromagnetic wave, which means it cannot reflect, it cannot penetrate through. Okay, means that if you have light go through black body, it cannot penetrate through because it will be all 100% absorbed, or it cannot be reflected because the light that emitted is from the black body itself. Example of black body I told you before, that is sunlight, sun, matahari. Sun is perfect, nearly perfect black body because it emit light. Okay, so you have to remember what is black body. Why black body can create such a like a wave or like something disturbance in physics world? Because when they carry out experiment to study black body, they found that it does not consistent with classical physics. Okay, so classical physics, the line of look at this graph, this is wavelength. Okay, so this is wavelength, okay, and then this is radiation intensity, or we can say that is the energy. Okay, it's the energy. Radiation intensity means that we study energy per unit of mass, per unit of something of mass, something like specific capacity, we have to study per kg, per degree Celsius, so that it is very accurate. Or in general, we just look it as radiation intensity is just like energy. Okay, so you see that if I have a red star here, okay, this is the experiment result. The whole graph here is experiment result. Red star is black body, right? White star also black body. Blue star also black body. All right, so they found that the black body, it will emit whole series like a spectrum of light of different wave, but there is a peak value here. You see that this is the peak value when the temperature is 4000 Kelvin. When the temperature is 5000 something Kelvin, they found that the peak value of the energy shift to the left. When the temperature increase, it continue to shift to the left. Okay, so they found that you see that this is the peak value. I will say this is the peak value, this is the peak value. Okay, so when the wavelength is getting smaller, semakin kecil, you see that the energy, the peak value actually going to the left, which means your energy is superpower when your wavelength is very small. Okay, which we don't really agree with it if we follow classical physics. Classical physics, we have this Rayleigh-Jeans theory. Rayleigh-Jeans theory original graph look like this. Okay, look like this. Okay, sorry, my line is not so nice. Okay, wait, padam. Okay, so the curve should be like this. Sorry again, where's my pen? Why I don't want to use my pen? Okay, so the curve is look like this. Okay, this is the classical physics theory. Okay, so it proposed by Rayleigh-Jeans law. Okay, so Rayleigh-Jeans law is someone that very great, so nobody doubt him, but they said that you see, if you compare classical physics and new, they call it new physics or quantum physics, they found that they are quite aligned when the wavelength is very long. This part, this is very long, right? It is not true when the wavelength is very small. Again, what did I say just now? I said if the wavelength is very small, when the wavelength is very small, very small, we said that it is micro world. We no longer can use classical physics theory to explain the phenomena. We must use a totally new idea, that is what you call quantum physics. So starting from here, when they study this graph of what you call that black body, a graph of black body, then they found that it is something new. That is something new when the wavelength is very small. Okay, you got my point or not? When the wavelength is very small, you see, the classical physics no longer fit to explain the theory. Okay, and then this is where we call it ultraviolet, catastrophe, like disaster, ultraviolet disaster. Okay, which scientists try to explain this part. You take out your notes previously that I explained. I saw that some of you write very interesting point here. Yes, this is the part that we study, and this is the part that we call it quantum physics. All right, okay. So far, any question? Any question? Any question? Understand or not? Or you sleep already? No question? Then I continue. I think today I can only explain 7.1. I only explain 7.1. Okay, so you have to be very clear. When we talk about quantum physics, it is something that very small as electron. Micro size. When it is micro size, we cannot use Newton anymore. We have to use quantum physics. Okay, so now we come here. Okay, let me continue. So this graph, you understand? No response. No response means that you understand. Okay, now idea that spark the quantum physics theory. All these things I don't want to repeat, because if I repeat, we cannot finish our lesson today. Now we go to quantum energy. Okay, so you look at continuous spectrum, which is we call it classical physics. It is continuous spectrum. When it comes to line spectrum, this is quantum. We only consider the maximum value, the peak of the graph. Okay, the peak of the graph, you see that this is one peg. It's already become satu peg. It is no longer continuous. So this one wavelength here, this one is classical physics. We call it wave. The line spectrum is quantum physics. Okay, so this is very famous line spectrum of hot mercury vapor lamp. Okay, so you see that the frequency energy of quantum, you have frequency, you can get the energy. You have frequency, you get the energy. So how to explain this quantum? And then you need some formula to explain it, definitely, right? So here we have someone that great, we call it Max Planck. Remember, this Max Planck used to be very handsome, but after he studied physics, jadi botak, right? Okay, so you see that you see quantum of energy is discrete energy packet. There's satu packet. It is not continuous energy. Okay, so the energy depends on the frequency. That Planck suggests that E equal to H. H is Planck value, Planck value, and then F is frequency. If you look at internet now, you see that most of them they write something like E equal to H mu. This is not V, this is mu. Mu also equal to frequency. Okay, so this different symbol that we use, so you don't get confused. Why I search internet it become like V? It is not V, it is frequency, mu we call it. Okay, so Planck constant 6.63. In physics we have three constant value that we call it great constant value. No matter how you tested the constant value, it is always correct. What is that constant value that you know? Physics, first one is Planck constant. Second one is speed of light. What is the speed of light? 3 times 10 to the power of 8, right? Meter per second, right? Another one, you learn it in Form 4. Guess what is the great constant value in physics? Anyone have a guess?
Gravitational constant.
Gravitational, yes, G, yes. What is G? 6.61 times 6.61 times 10 to the power of negative 11. Is that correct? 6.67 or 6.61? 67. Okay, 6.67 times 10 to the power of negative 11. So those are the great value in physics. You study physics, you have to know these 3 great value that nobody can chaba, nobody can challenge. Okay, so Planck constant, speed of light, and also G, big G, that is Newton universal law, that it can be used in a very small apple to outer space big planet. We apply this value, so you see how great it is. Okay, so when we come to very small world, we call it micro world, we have Planck constant. Okay, so when Planck proposed E equal to H frequency, he himself also doubted this number. He tried to explain the graph by introducing this formula, but he also not so confident with the formula by himself. Okay, but after that, Albert Einstein agree with him. De Broglie also agree with this. They continue to carry out a lot of experiment which only can be explained by this formula. So in quantum world, this is like datuk lah, moyang. Okay, so moyang formula you have to remember. Energy of satu bag quantum, it is equal to H Planck value times the frequency of the light or electromagnetic wave. Okay, now we look at the question. Okay, we look at this question. I know that when you study theory, okay, I understand. But when you come to a question, you cannot understand, right? You don't know how to answer. Okay, now look at this one. Quantum theory. I will post this thing, the whole thing, because it's quite long, to class group, then holiday. When you have study group, please study this. Number 1, look at number 1. Okay, which of the following is not related to classical theory? Classical theory, you look at the word, immediately the tokoh, the scientist or the physicist that came in your mind will be Newton. Okay, Isaac Newton. Okay, study of motion of everyday object, force that affect them. Yes lah, of course, Newton about something big. Describe a behavior of most objects which are larger. Yes, smaller than a planet. Okay lah, because we said that Newton theory cannot be used or not applicable in micro world. Okay, see, describe the behavior of most objects come close to room temperature and going at speed significantly slower than speed of light. Yes. Okay, speed of light, nothing can be greater than speed of light. D, state that gravity is not real force. You sure gravity not real force? Then you are going to select Sir Isaac Newton, because Sir Isaac Newton talked about force. So answer obviously is D lah. Gravity is not real force, that it is merely an inertial effect similar to, it is not inertial effect. Force is force, inertia is inertia. Alright. Okay, so number 1 will be D. Number 2, classical theory also known as following except classical physics. Classical theory is classical physics lah. Oh sure lah. Particle physics, classical mechanics, or Newton mechanics. Which one you think? Number 2. Answer is
B.
Yes,
B.
particle physics. So smart Wow, yes, particle physics. Particles is not about the classical can be very huge, planet can be not from molecule it go to planet, okay, like from apple it go to planet, universe. Scientists that not contribute to quantum theory is who? Neil Bohr talking about the energy band. Albert Einstein, of
J.J.
course.
Thomson.
Yeah, J.J. Thomson, sangat-sangat tua. J.J. Thomson about atom mah. Quantum energy refer to, this one, number 4. Quantum energy refer to?
C.
C, discrete packet of energy. Yes, discrete. Spectrum is continuous. When we talk about quantum, it is discrete. Remember? Okay, number 5. Finally, we have something about calculation. You see that determine the energy released by quantum of radio wave with frequency. Okay, you want to know energy. We have so far until now today, I only introduced one formula, right? That is formula of what? Of Planck, H frequency. So Planck value, in exam Planck value will be given, which is equal to just now 6.63 times 10 to the power of negative 24. If you don't know, you also can get it Planck value in your calculator. Okay, and then frequency you darab lah 103.3 mega tera giga mega 3, right? Tera giga mega 6. So you got your final answer. What is the final answer for this one? You tekan your calculator lah.
D.
D sudah already more or less like that lah. Okay, so that is how you calculate. You remember the calculation for quantum is not hard. It's just like E equal to mc squared. So easy. Just the theory that you have to understand. That is the hardest part. Okay, so which of the following is the evidence of existence of discrete energy? Discrete energy. Line spectrum, spectrum of visible light, Young double slit, Dalton atomic theory. Which one proves that we have quantum? Like, someone answer me.
A.
Yes, A. Very good. Yes, line spectrum of mercury vapor lamp. Baru saja cikgu tunjukkan. Okay, so now determine the momentum. Okay, momentum is another new things that I know they explain today, right? Okay, if you continue to look at the textbook, okay, so this is what you call Planck value. As long as you have frequency or you have wavelength, you basically can calculate energy of quantum of the back. And then we have this duality, wave particles duality. This is if you still remember previous lesson, I said that de Broglie is the scientist that he reversed others people experiment and then he won Nobel Prize. Remember, he said, okay, you said that particles or light is wave originally, initially, anciently, wave is light is wave. Now you tell me that light also can show particles property, which is discrete when the wavelength is very small, right? So de Broglie reversed it. He said that particles also has what you call a wave property. Particles also have wave property. Particles is discrete, right? It also can show wave characteristic. You see that? Okay, de Broglie hypothesis stating that all particles can exhibit wave characteristic. However, it is experimentally difficult because same thing. Just now we want small wavelength, now we want small mass. Only when it is small mass, it will show opposite characteristic. Okay, when the mass is very small, what is the lighter particles that we have? Electron. So these are de Broglie actually his hypothesis is for small particles. Okay, so how de Broglie got this formula? Momentum equal to momentum equal to Planck value divided by wavelength. How he got that? We know that momentum equal to mv, right? When it is light or it is electron jump here and then it produce light, so I will say that it is equal to mc. Velocity, where I change it to speed of light. Okay, so this will be my first formula. Another formula, E equal to mc squared. So I can see that m actually equal to E divided by C squared. Okay, am I right? Number 2. So I substitute this one, I don't want mess. I substitute number 2 into number 1, so I can say that my momentum is actually E C squared times C, right? C and C cancel. So I say that momentum is E divided by C. What is E just now? E is what? From Planck. E is this one. Okay, so E is this one. So H frequency divided by C. Okay, so now I know that my momentum is H frequency divided by C. So you remember when we study wave, V equal to F lambda. So now C equal to F lambda. So F divided by C will be equal to 1 per lambda. Correct or not? Ini letak sini and then this one here. So this F divided by C will be 1 per lambda. That is how De Broglie won Nobel Prize by reverse the theory, the original theory from this Planck. Okay, so you see that he said that particles also exhibit wave characteristic, which it has momentum. Remember we said wave actually transfer energy and momentum. Okay, so you have to use momentum and energy formula to prove that it has wave characteristic. Okay, that is this one. So you must understand how you got this, but exam that will ask how to calculate. So all in all, you just memorize the formula. Very simple one. Just now energy equal to H frequency, right? H frequency, and then now momentum equal to H divided by lambda. H divided by lambda. Okay, now we go to the just now question just now. Okay, so what is the momentum of photon? Momentum of photon, since that we already know, okay, since that we already know momentum is, where is my pen? Okay, we already know momentum is H divided by lambda. H is Planck value. Okay, Planck value 6.63 times 10 to the power of negative 34. Okay, then masukkan saja lah. Lambda, masukkan lah. You change Newton to meter lah. Then you got your momentum. Okay, so for the first part of this chapter, it is not so hard. It is not so hard. You have only two formula for 7.1 quantum theory of light. You have only two formula. There is energy equal to HF, Planck value and frequency. Second one, momentum equal to H divided by lambda. Okay, now this one also the same. A photon of electromagnetic wave has same momentum with electron. Okay, means that H divided by lambda equal to H divided by lambda law. Okay, move with speed of this one. What is the Broglie wavelength? Okay, what is the Broglie wavelength? Okay, so you use momentum of an electron, this one. Sorry, you use momentum of electron is mv law, equal to P equal to mv, you know, right? P equal to H divided by lambda. This one you use electron mass of electron, and then the velocity of electron already given. Okay, you masukkan, and then you have Planck value, you can calculate this one. Alright, the mass of electron also given, so you can easily calculate the answer. Okay, I hope that when I show example like that, you can understand better lah. Or else I really don't know how to make you remember all those things. Okay, so this one also not so hard. I will leave all to you until question 13. Okay, until question 13. Then we have photoelectric effect. Okay, so any questions so far?